Right. Morning, everyone. Yeah, it's almost the graveyard shift between a few bleary eyes and morning tea. John's been pestering me for a while to talk about the pros and cons of liquid nitrogen products, given the rapid increase over the last decade of volume and range of application techniques of liquids. And just in my short career in that area, when I started with Nipro back in 2005, we might have delivered one load, 20,000 litres of product into cereal crops. And by the time I finished last year, I think we would have peaked at somewhere between 50 and 85,000 hectares per season being treated with liquid nitrogen if you looked at a 20-unit shot. So, that I just picked those numbers to give a relative increase. So, a significant increase in volumes, and that's been driven by price, product mix, and growers having the ability to apply products. So, down. To put this into presentation, it was quite difficult, so I thought I would break it down into the 5 most asked questions of me during my time of liquid nitrogen products that growers and consultants would find themselves in a situation ready to use it. Commonly, what's it cost? Can I put it on the ground? Am I going to lose the nitrogen if it doesn't hit the plant? What form of N? Is it going to be possible to mix it with other operations? Can I put herbicides, insecticides with it? What can I do with it? Is it going to burn? How much? How much burn can I take? What conditions are going to give me burn? And what's the application going to do for the timing? Is it going to increase yield or protein? They're the main questions that we found ourselves asked. Now, what's out? This is a fairly busy slide. Looking at formulations, I've stuck to bulk liquids. So, forgive me if anyone else has got a product out there that has trace elements or safeners or that's in smaller packaging. I'm dealing with the bulk liquids that are going up against spread urea or pre-applied nitrogen. So really, it's the same nitrogen forms that you get in solids. It's just that they're a liquid. There's a couple there like UAN that obviously is not a solid. It's a eutectic solution that the combination of urea and ammonium nitrate gives you a higher concentration. So UAN's probably the only one there that's and ATS, ammonium thiosulfate. They're probably the only two that are solely liquid products. But the rest, they're liquid forms of the various solids. They have a range of characteristics. Probably the most important ones are whether they're useful for soil or foliar. As Chris alluded, there's a lot of work being done all around the world on what to put on the leaf as a foliar form of nitrogen. And everywhere I looked in my wide reading on that topic was urea was the molecule of choice. It just kept coming back to urea. It's very, very mobile. It's non-polar. It's an excellent cuticular penetrator. Gets through wax. It's the molecule of choice for the leaf. And those of you that do read on the subject and have a look in my paper, which I didn't manage to get to Erica, apologies, on time, but will be distributed. I've got some references there of some excellent work that's been done on the topic. And one guy, Wayne Strong, back in 1982 up on the Downs, did what I regard as foundation research on foliar urea. And it's been done. It's not new. So, all these other products, whether they're soil or foliar, largely to the degree of their salt index, whether they'll burn the leaf and whether they're readily uptaken, and then the soil potential application, the volatility has a factor as to whether you need incorporation or not. And I've got a few things there not to mix. We'll get into that later. And the corrosivity has a large degree to use through things like camera sprayers. For example, I'd be very, very nervous about putting, straight ammonium nitrate or straight ammonium sulfate liquids through a camera sprayer without, really looking after your electrical connections because they're just so aggressive on brass, bronze, galvanising. You'll eat some very expensive equipment very quickly. So, comparing the cost, I've deliberately chosen a 30-unit shot of N to demonstrate that the unit cost, when you look at urea, straight urea, unit cost about $1.30 to all the liquid forms is significantly cheaper. So a grower, consultant, anyone that's looking at the facts on paper, unit for unit, that's going to come out in front every time, and gas is even cheaper, usually. So, but when you look at the applied cost for a 30-unit shot, and I've just picked some figures here that some people argue are too high or too low, but just standard application rate, $36 for a disc rig plus fuel probably, and $16 for a spreader, and $10 and $9 for, depending on whether you're under or over 100 litres. When you're looking at the cost of application or the applied operation, there's not a lot of difference sometimes in the liquids, and sometimes you're getting to a point where you can't do other things anyway. So in the north, where the rainfall events to incorporate have been a little less than reliable, sometimes been pushing, and certainly in the business I was involved in, we found ourselves pushed towards growers wanting the foliar option because they just couldn't make the spread, either logistics or timing of rainfall work for incorporating the ground spreading always. So having that liquid option as a foliar was a good one. I'll touch on losses briefly. They're liquid forms of solids. So if you get loss, I'll probably take a slightly more conservative approach to some at the moment, with urea being applied. I believe surface applied urea, I don't see why we're any different to anywhere else in the world. There's volumes of data suggesting that it's open to volatilisation if there's moisture and urease. And that's a key point. On dry soil, and I'll show you on the next slide, this is applied to moist soil. So that's urea ammonium sulphate, liquid urea, solid ammonium sulphate, liquid ammonium sulphate, and liquid ammonium nitrate. It's not very clear there, but you can see that there's very little blue in these tubes, and the tubes filling up to the top is 15% loss if you follow this is a test kit done by Yara that demonstrates surface applied losses. And the data behind that shows pretty clearly that this is just a simple numbers I came up, not highly replicated, but just as a demonstration that within 5 days in February, temperatures 12% loss from UAS, 8% from straight liquid urea, 7% from UAN, and your ammonium nitrate and your ammonium sulphate on that particular soil with, I would argue, probably low carbonate is quite minimal loss. But I would stress that if you're putting nitrogen on the soil, I'd advocate it incorporation by rainfall or mechanically. The Drager tube is readily available. They're a safety tool used by industry to detect ammonia, and the researchers in the Hanninghoff lab for Yara had worked out a ready reckoner, and I'd encourage people, if you're wondering about losses in your own soil, it's not hard to do. You grab a handful of soil, put about 10 drops of water in it to moisten it, and throw some nitrogen in there and see what happens. It certainly, if you've got doubters, it demonstrates to growers pretty quickly the difference between losing some and none of the different end sources and whether you'd be prepared to lose it. Is it going to burn? Nitrogen on the leaf is always a risk. And there's various reasons for that, and plant stress is a key factor along with the size of a canopy. So if you're applying nitrogen to a leaf and the plant is stressed, be that from frost, heat stress, high evapotranspirative load, the urea being very, very mobile moves straight to the leaf tip and the margins, and you end up with quite visible damage, as the next couple of slides will show. And it is urea toxicity that is causing the damage. There's been some work done with urease inhibitors trying to prove that it was ammonia toxicity, but it's actually urea toxicity because it does not change when you suppress urease activity in the leaf. So it's quite clear that it's urea. And the application technique also, mechanical damage and wind are two key factors when you're looking at foliars, because they loosen the waxy cuticle. And I've seen a lot with people using lower set spray rigs like a Land Cruiser Ute or a JCB that's set up a bit differently to the high clearance sprayers underneath the machine, where those vortices are having a large effect on the crop, or actually physically touching the crop in some cases. You'll see much more rapid uptake of the nitrogen, and by the plant trying to metabolise it, shoots to the leaf tip. Propiconazole is another thing that is an absolute no-no to mix with products, liquid urea products particularly, or UAN, Ranger, Easy N, Promax, any of those, because of its activity. In the GRDC, it was very interesting last year to look at the various modes of action of fungicides in those foliar fungicide workshops, in that propiconazole came out as, funnily enough, that moved very rapidly to the leaf tip, and when you combine that with urea, you get both of them there at the same time and get quite significant damage. And you will get a phone call. That doesn't show up quite so dramatically as it looks in real colour, but that was a boom section turned off, and it looked like it had been sprayed with spray seed. It was really, really ugly scenario. But in 10 days' time, you couldn't tell that any damage had occurred, and in measuring that, there'd been no measurable loss. So I encourage people, if you do find yourself in a situation where you have caused damage, or a grower has caused damage, make sure you're objective. It's pretty emotional. People get the phone call with their mate driving past saying, "Oh, why'd you spray your wheat out?" And rarely until you get to flag leaf or flag -1 or 2. I certainly haven't seen it in northern New South Wales, where we've suffered a yield penalty from damaging a crop. I know CSBP's done a heap of work in the west where it was only once they were damaging flag 1 and 2 to a significant degree that they were able to induce yield loss, and I think it's something like 50% flag leaf damage, they induced about 12% yield loss. So, yeah, I'm not encouraging people to go out and burn crops by any means, but just if you do, and you will, as you get into foliar application, measure it objectively. That's from frost. Any plant stress that slows the crop down, you'll see damage. And at these early stages, it's fairly aesthetic. Propiconazole damage, I don't know how clear that is again. You can see 30 to 50 mils of the leaf tips quite badly scorched. Again, I wouldn't recommend that mixture. And then applying nitrogen for yield or protein, what's the timing? Basically, anything prior to anthesis in the work I've done at Yarra and what I've read, basically the timing for manipulating protein is right at flowering. Now, if you're close to the mark with nitrogen, then that can be achieved from flag leaf onwards, but it's quite dependent on the environmental conditions post-application. So the soil applied top dress is all the products are fairly well applicable for putting through a streaming nozzle, and incorporation is determined by what form of N you're using. With UAN, obviously you've got a 50-50 of low volatility and high volatility, and once you slip over to the liquid urea and UAS, you've got a much higher chance of volatility if you're not getting rainfall incorporation. With the cost and operational benefit of where liquids fit, I found that often the cost was a secondary issue, because the reason that a lot of people were using liquid was purely operational, or the convenience factor of having a remote site that they couldn't get solids to, so they wanted to just put a tank there, and they send their spray contractor there and he pumps out of the tank and the job's done. And the cost was a secondary thing that they recognised but accepted because it was an operational issue. Through streaming nozzles, a tip, don't apply to a wet canopy. You'll see very, very clearly as you go through the day. If you start during heavy dew, you'll get quite extreme burn early in the day from canopy retention, and you get the same type of scorch as you get from liquid urea products as a foliar. And you will see some spot burn from canopy retention if you're using ammonium nitrate and ammonium sulphate, but that's purely a desiccation, the same as if it was a spot of spray seed. So, but early in the morning, watch out for heavy dew, wait for the canopy to dry. At booting, in the south and in the west, there's a lot of applications going on with pesticides early, right up from basically 2-leaf stage to booting. In the north, I've seen most of that happen at booting stage, which is largely for yield. So again, people that are maybe 20 units short go in and put a shot on as the flag's coming out or just before, often with a fungicide. There are products that are quite compatible. The SC type formulations seem to work quite well with urea. Don't know what I don't know if there's been any work done. I know New Farm and Bayer and Syngenta have all sort of talked about it, whether or not the cuticular penetration has any effect on how quickly those products do move up the leaf and whether that changes their dynamics in disease control. I know in the UK they looked at septoria and found that liquid urea products applied foliarly with fungicides actually had a dampening effect on septoria, and they don't know whether that was just purely the urea damaging the septoria or some other effect in plant health, not sure. There's lots of things that are compatible with liquids and the foliar application methods. However, I would advocate that anything that is taken up through the leaf faster you're going to get more of that chemical into the crop, and you may reduce your selectivity. And certainly we've seen crop damage from anything that's harsh on the crop mixed with foliar nitrogen. I would view as a no-no, but quite commonly put out with insecticides, aphicides and fungicides. Watch out for the ECs in the fungicides. This is a graph with the three lines on this graph. The top one there is a R squared of 0.99. The middle line is an R squared of 0.92, and this line here is an R squared of 0.7. Looking at the timing in days post-anthesis, so from starting 60 days before flowering to 40 days after flowering, and the likelihood of a nitrogen response, protein response to foliar applied nitrogen. You can see that right around anthesis is the timing, and certainly with commercial results that I've had feedback from growers where they have applied a 20 or a 40 unit shot on big durum crops and big Gregory crops, that has been the timing where we've had really good success. The difficulty in our environment in jagging that timing is having the canopy in a healthy situation that's going to be happy to take up nitrogen, and secondly to get the environmental conditions under which you'd be happy to apply it. And usually that coincides with 50 mil rain event right near flowering. That's what I call that'd be the sweet spot for me if I was going out to try and change protein. So in other parts of the world, Newfol, Profol, they're two big products in England, and to put that into perspective, I think Newfol, they do about 200 million litres of that product a year, just chasing protein, so it's widely done. I know that there's a couple of projects going on to have a look at that. So, and I've got some resources at the end of my paper to have a look at. There's a lot of peer-reviewed data if people are interested. I think we've covered fair bit of that. 20 kilos of nitrogen, in my experience, has been yeah, seen at flowering to increase between 0.5 and 0.75. That's a general rule of thumb where commercial operators have split paddocks and left strips out and got back to giving us feedback. That's often where we've seen operators get their money back quite well, depending on the payback on protein. So I think a calculator like what Chris put up is probably a really good idea, because there are going to be years where it's just not worth doing, and there's going to be other years where it pay for itself in multiples up to 5 times or something. Additives, safeners. There's a lot of talk about non-reducing sugars and other things that people claim putting into liquid products. I've certainly looked at a fair few of those over my time and haven't been satisfied that any of them do anything. Some of them, I believe, anecdotally, I've heard that there's been some organic substances added that have reduced burn, and I would ask the question: if the burn is from uptake of nitrogen, is the safener actually reducing the uptake is it stopping and getting them into the plant in the first place? And that's certainly, my experiences in the UK, no one was talking about safeners that did anything. It was all about the environmental conditions, applying it in the cool of the day, late in the afternoon, high water rate, and a canopy that was large enough to take the nitrogen that you were throwing into it. They were the main ways to safen it. Getting the cut the throat here from beads, so I'll shoot through the last few slides. I've got a few, just what's happening in other places. Interestingly, in the UK, the Arable Group did a large volume of work over 5 years looking at foliar nitrogen in canola, and found that irrespective of yield potential, they were able to bump yield by 0.3 of a tonne in canola with applications just at petal drop. So they were waiting until, mainly because the petals don't take up nitrogen, so it was shading out the rest of the canopy. They're finding that a shot of N at that late stage with moisture, or actually their best results were in tight springs, but they were finding that was just bumping the yield potential of oilseed rape in the UK. New stream bars out. These are in Australia. The stream bar MR, you've got multi orifices. This is a new one that I saw last year in the UK. It's got a reducing orifice like a flow restrictor in here that's spring loaded, so it just responds to the pressure of the spray rig. So you can just basically put it on, set your rate controller, and it puts out the rate that you set. So the guys that were using it were saying that between 1 and 3 bar they were able to change between 40 and 400 litres at 18 k's. So pretty impressive bit of equipment. Spoke wheels, we've seen those come and go, but there's some new ones in the UK that are looking quite interesting. And front tatch coulter rigs that the high capacity of liquids. These are just literally clip on and clip off onto a nitro or a housing. The big capacity sprayers, they were quite interesting last year as well. So I'll take home messages. Look, soil and foliar N both have a fit. Liquids certainly can play a part in that. For foliar application, I wouldn't go past urea, apart from convenience. There's certainly some logistical issues that would suggest that there are times when UAN, getting twice as much nitrogen in a truckload, has a place, but it's very, very unpredictable with leaf damage as a foliar. And if you've got temperature conditions less than 18 degrees and no frost and things are going away, then UAN is a good choice. And as soon as you start to get above 18 degrees, the variability and unpredictability of causing leaf damage increases quite incrementally. Surface applied liquids, in my opinion, need incorporation. I haven't seen anything to suggest that surface applied nitrogen is a good idea without incorporation by rainfall or mechanically. Certainly I've seen people get away with it, and sometimes a little bit unexplained as to why they have got as much uptake as they have, or haven't sustained the losses that they should have, and I would put that down to N form. Look at the applied cost per hectare rather than necessarily just the unit cost. Scorch will always be a manageable risk. So if you're putting stuff on a leaf, if you're putting liquid out through a boom, there's always a chance you can burn it, and it needs to be managed. And if growers and consultants are well informed with the product they're choosing and the conditions they're putting it out in, then you shouldn't have any dramas. And your timing, that will be a key factor as to whether or not the nitrogen you put on is influencing yield or protein.
Thanks a lot, Stu. Is there any questions or comments about liquids? Anyone would like to put their hand up? No, everyone's pretty excited about smoking. Oh, there's two. Now, hang on, we're going to Gilbert here first.
So, leaves actually decline to assimilate nitrogen fertiliser. I mean, I would have thought they've got a couple of roles, but that's not one.
What?
So, what evidence do you have to say how much foliar actually goes into the system through the leaf, as opposed to what drops in the ground goes in another way?
Well, how big's your canopy, Bill? Yeah, well, if you've got a full canopy, and you could guarantee 100% canopy capture of what you're spraying out, then I would suggest that it'd be better than 70%. And there's a lot of work from all over the world that supports that. If you Gooding Davies is an excellent resource if you want to look at. Yep. No, it's well researched that, and in all sorts of crops, urea does get it. They've done it with N15 label urea, and it will go into the leaf and it will translocate to fruit parts very, very quickly. The key issue is, are you capturing it, and is it staying as a solute? Because that's the big difference between UAN or an ammonium sulphate compared to urea. Is urea dries as a crystal when the moisture dissolves, and it will sit there on the leaf. And I had some crops last year that you could see the physical urea crystals. We didn't get any dew after application. It sat there for 8 weeks, and that wasn't particularly successful. And another couple of crops, we got the timing right and got heavy dews, and the uptake was within a week, and we had a really good result. So I think that's a key thing, perhaps, that certainly I know that we had overlooked in the early days, was the influence of it will only penetrate the leaf as a solute, and that's where UAN, it stays oily, and you can cop burn at any time because it sort of stays as an oily sort of substance on the leaf rather than a solute.
Question right up the back.
Yeah, just a question about the timing of application. Would you recommend putting it on at night simply because of that reason, like with dews and burn? Is it better to put it on at night or in the day?
Oh, absolutely. If you can start late in the afternoon, that's certainly late in the afternoon right through into the night. That reduces the risk. If you're talking foliar, once you get into the streaming operations, you've got to be careful, because once the dew starts to settle, then you start to get canopy retention of the two different operations. One's designed to roll off the leaf and hit the ground, and the other one's designed to be captured by the leaf. So if you're doing stream bar jobs, I'd be doing that in the daytime and through into night time before the dew falls. And then if you're doing foliar operations, the cooler it is, the better, because your droplets stay as a solute for longer, so you've got more opportunity for uptake, and your heat definitely won't give you damage if you're starting it late in the afternoon. And we saw some guys, we did some trial work down at Gunnedah where they put out up to 50 units of N as a foliar onto a good canopy, a big, strong durum canopy, and suffered. You could barely see the nil strips as far as leaf damage goes. That's getting to the extreme end in my books of how much you'd be putting on as a foliar.
And would it uptake before morning, say? If you put it on at, say, midnight, will it uptake that quickly if there is moisture in there, dew? Yeah, you'll struggle to find anything on the leaf the next day if you've got a good strong canopy and moisture there.
Right, to wrap it up there, in the interest of time, everyone would join with me in thanking Stuart Doyle. We're in a bit of a rush to get our share of smoko. Chris.